So we were discussing about the problems on cantilever beam. So the next the next question has been, most of the time in your examination point of view, sometimes they will give you the diagram, sometimes they will not give you the diagram. So you should be ready to handle the problems in both the ways, either if they have given the diagram or not. So let us take a problem in which they have not given the diagram, just they are giving the question in terms of words. You have to identify what is given, what is not given. So they are saying that it is a cantilever beam of length 2 meter carries UDL of 1.5 UDL of 1.5 kilonewton run over the entire length. Entire length means it is being spanned for a length of 2 meters and a point load of 2 kilonewton at a distance of 0.5 meters from free end. Draw Sfd and Bmd diagram. So let us draw the first question. We will convert into a diagram, then we will try to solve it. Okay. So when we convert the diagram, is the first thing we have to understand is it is given as cantilever. So let us first draw a cantilever. So what is cantilever is one side fixed, another side free. So one side I have fixed, another side I am drawing free end. Once you are done with this, what they are saying, there is a UDL for entire length. Entire length I am drawing. So I have drawn entire length. So what is the value for this? They have given it as 2 meters length of 2 meters. So I have done 2 meters. So after 2 meters, they are saying that from free end at a distance of 0.5. This is free end. From here I have to travel a distance of 0.5. So let me travel a distance of 0.5, which is I have traveled and reach a point. So at that point there is a point load which is acting in downward direction, 2 kilonewton. So which is they are saying it has to be 2 kilonewton, 0.5 meters. So I have traveled and I have reached a point where they are saying that there is a 2 kilonewton load. Let us try to give the namings for this. So first name we are saying that, so this is the point A, this is point B, and this is your point C. So we have got this. So I have already told, once you draw the diagram, keep this entire space by extending the lines where you have to where the loads are present. I am extending that to draw the shear force and bending moment diagram. Okay, clear? So I have drawn this. Use the scale or whatever, you can draw it roughly also. So under the question I am trying to solve it. Okay, so first question is, first whenever you find this type of problem, what we have told is you should write a condition, that is beam is under equilibrium. Beam is under equilibrium. When we say equilibrium, we have to see that summation of horizontal forces should be equal to 0, summation of vertical forces should be equal to 0, summation of moment is equal to 0. Next thing, when you write this equation, you have to identify that since we are having a fixed end here, we will be having a reaction A vertical direction and a horizontal direction will be having a reaction. Okay, so next is we will solve this summation of horizontal forces, summation of vertical forces. In horizontal force we had only HA, so that is equal to 0. So this is because of this. Next is I am trying to do summation of vertical forces is equal to 0. So we write here upward forces is equal to downward forces. Upward forces is equal to downward forces. Okay, so what are the upward forces here we are acting is RV, that is we write it as RA, because at point A it is fixed. RA is equal to, what are the forces acting in downward direction is 1.5 into, what is this 1.5, this 1.5 is the value of UDL. 1.5 is the value of UDL. You can see here this is 1.5 kilonewton per meter. 1.5 kilonewton per meter. So what is this 1.5 kilonewton per meter is nothing but, you have to understand that this is per meter. So you have to multiply with the entire length. So what is the entire length of the UDL? In the question they have clearly mentioned it is for 2 meters. So 1.5 into 2 plus what is another load they are acting? There is another point load which is acting downwards, plus 2. So 3 plus 2, you get the value as 5 kilonewton. 5 kilonewton. So Ra value we have obtained as 5 kilonewton. So highlight this point. Okay. So once you are done, go back to that diagram. As soon as you get the values, write it here itself. So Ra is equal to 5 kilonewton. You have got Ra is equal to 5 kilonewton. Ha value you have got 0, means no need to write this diagram. So if you get any value for the horizontal force, then you have to draw the horizontal shear force diagram, but most of the time you will not get horizontal reactions. Okay, clear? So once you solve this, I will go for shear force and bending moment calculation. Let us draw the shear force and calculation here. Shear force and bending moment calculation. So what is shear force and bending moment calculation we have studied? So first thing is you have to write the sign convection. So I am writing to the right corner, always have this sign convection. So what is the sign convention? Since we are solving from right to left, downward force is equal to positive, counterclockwise movement, CCW movement is equal to positive, counterclockwise movement is equal to positive. Since you are having 3 points here, one is C, B and A. Let us solve it. Shear force calculation. We already know how to draw the shear force calculation. Okay, so I will try to solve the shear force calculation. Okay, shear force calculation. So I will try to draw the beam here for my simplification. Done. Clear for you? Okay, so this is point A, this is point B, this is point C. So this is no need to draw in examination, just for the sake of your understanding I am writing this every time. So next is shear force before C. We write before C. So what is before C? There is no load acting before C, so this is 0 kilonewton. Next is shear force at C. Shear force at C. We are having UDL, but the length of that UDL is very less, so that is also equal to 0 kilonewton. Okay. Next is shear force before B. You can see the diagram before B. Okay. So before B means we have to consider the UDL only for this particular length. You should not take the UDL for this, because before B means only this much amount of UDL is present. So what is the length of this UDL? 0.5, that is 1.5 into 0.5. Since this is only for the length of 0.5. Okay, so what will be the value for this is 1.5 into 0.5. Let us do the calculation. 1.5 into 0.5, you will get the answer as 0.75. You will get the value as 0.75. So I am writing 0.75 kilonewton. Next is shear force at B. So when you reach point B, you are having a point load which is acting downward. So 0.75 plus 2. Why plus 2? As soon as you reach a point B, there is another point load of 2 Newton which is acting downward. If it is acting upward, we will do minus. So the value is 2.7 kilonewton. Okay, clear? I hope it is clear for you. Next is shear force before point A. Before point A means we are having entire UDL as well as a point load. So entire UDL means 1.5 into what is the entire length of the load? So that is 2. This is length. Okay, length I will write here so that you should not get confused. 1.5 UDL, 2 is length, plus 2. Why here 0.5 we have taken is because that is present only for that particular length before point A. Okay, I will write here if you want. Before point B, length of UDL, here length of UDL before A. Okay, so the total value will check here in the calculator. We can do calculation. 1.5 into 2 plus 2, so we are getting the value as 5, we are getting the value as 5 kilonewton. Okay, so once we are done with this, we will solve it for shear force at A, shear force at A. So at A, we have to consider all the loads before A and at A. So before A it is 5, so which is acting in downward direction, minus at point A we are having an upward reaction force which is acting upward direction. This is downward, that is upward, so minus. So what will be the answer? 0. What will be the answer? 0. So once you get this value 0, next is 0, next you are getting 0.75, 2.75, next we are getting 5, next we are getting 0. Once you get this value, let us draw the shear force diagram. So first you have to draw a baseline. First you have to draw a baseline. Okay, so baseline once you have drawn, let us go for the values. First value is 0. Next value you have got it here as 0.75, 0.75. Next value we have got 2.75. So okay, so 2.75 at B itself we have got. So both values are at B itself. So one is before B, one is at B. So before B means just before the point B. Okay, this is the point we have to show, but we can show it on the line of B itself, because the distance between the before B and the point B will be very less. Okay, so we will continue here. So this is 2.75. next is 5, next is 5, from 2.75 to 5, next 2.75 to 5, next the value is 0. Now you have to join these two by using lines. So this is a inclined line. Since these 2 points are on the same line, it will be joined by a vertical straight line. Since these two are on opposite side, we will join this by using an inclined line. When it is joined, then you have to join these 2 points which are on the same line by using a vertical line. So the value of this is positive. If you measure the distance, so this will be equal to 5 kilonewton. 5 kilonewton. If you measure this distance, so this will be equal to 2. So why this extra 2 is coming is because of this point load. If this is not there, you have to join from here to here directly. So from here to here, whatever we have to join directly. Okay, clear? So this is positive shear force diagram. In this way we have to draw for shear force diagram. Let us solve for bending moment. Let us solve for bending moment. Okay, so I will solve it here itself, no problem. So bending moment calculation, this is the procedure. First you have to solve for equilibrium conditions, then you have to solve for shear force calculation, then you have to go for bending moment calculation. So according to bending moment calculation, we have bending moment at point C is equal to 0, because there is no right side load at point B at point C. Next is bending moment at point B. At point B means, since the diagram of your whatever the question has been given, so I am rearranging the diagram. You know this is the diagram which they have given. For your understanding itself, I am writing every time. So this is the right side to be, we are having a UDL. So that is 1.5 into, so to what distance it is present before point B? It is 0.5. So this is completely load before point B. Now what is the distance of this action, point of action of this UDL? Since this is acting every point, we have to consider a point where it will be concentrated. For example, if your body is completely having a muscle, but your CG will be present about to a center. Every body will have its own CG through which its entire mass will be concentrated. Similarly, for this body, the entire force will be concentrated about the half of its length. So since we are considering only this length, so the CG will be concentrated half of this length, that is 0.5 divided by 2. So do the calculations for this. So what is the value we are having? 1.5 into 1.5 into 0.5 into 0.5 divided by 2. So the answer you are going to get it is 0.1875. Okay, so I am writing the value 0.1875. I have told that you have to consider the sign convention also. Once even you have solved the problem, then you have to check is this correct or not. Okay, so once I am done, I am checking the sign. So in which way it is trying to rotate? It is trying to rotate in clockwise, so I am giving minus. Okay, next is bending moment at point A. At point A, this is your point A. So at point A there will be bending moment because of this UDL as well as the point load. First we will write because of UDL minus 1.5 into from point A to point C before point A. So to what length the UDL is present? The UDL is present for the entire length. So I will take 2 into, so what will be the CG for this entire length? Will be half of it. That half to this point A will be exactly equal to 1. Okay, that is nothing but 2 by 2 plus, or since this is also in clockwise direction, we will take minus, what is the load of point A is nothing but 2 kilonewton into distance of this point load to point A. Point load to point A. Point load value is 2, but they have given the value of B to C distance as 0.5. So what will be the distance? Total is 2, means 2 minus 0.5. 2 minus 0.5. The value will be 1.5. So if you do this calculation, you will get minus 1.5 into 2 into 1 minus 2 into 1.5. So, you will get it as a minus 6. You will get the answer as minus 6 kilonewton meter. Okay. Once you have got the values, we will go for bending moment diagram to draw the bending moment. Shear force we have already done. All the values we are getting in negative. So, let this be in a negative direction itself. So, this is your, this and this both are your baselines. Both are your baselines. Okay. This is for moment. This is for shear force diagram. So, here we are getting 0, next value you are going to get it is 0 to, you have to change it from, if you see the values of it, you are going to get it as 0.87, negative 0.87. So, I am drawing negative. Next you are going to get the value as 6. Okay. So, see, if it is, already have told, if it is an inclined line, if it is a inclined line, you have to join these two curves by using a somewhat curvature. You should not use a inclined line. If shear force is having inclined line, your bending moment will have the curve path, that is nothing but your parabolic curve. You can write here, this is inclined straight line, inclined straight line. Here it is a parabolic curve, parabolic curve. Next, from this point to this point, again you have to join, since this is also inclined. See here, this is also inclined. So, how you have to join these 2 points? You are using a curve, using a parabolic curve. So, this is negative curve. So, what is the length of this value? So, the entire length of this is nothing but 6 kilonewton meter, and this is your bending moment diagram. This is your bending moment diagram. So, if you have any doubts in solving of this, please try to write in your comment section, or you can directly text me on my number. Okay. So, try to solve this as many a number of problems as you can solve. These which I have been solving is the university question papers. So, same types of questions has been asked n number of times. So, try to solve as many number of problems. If you have any doubts, we will try to discuss. Write in your comment section. We will try to discuss as many number of problems.